I think that pattern of just starting with one bit, like one package, one thing, even if you're just adding a feature, I like to start in one place and do that proof of concept. It should be that iterative approach, right? Where you're getting it working and then we can go back and organize if we need to. But avoiding that premature like organization and abstraction and all of that, I think is probably the most important part of the job.
This episode is brought to you by our friends at Square. Millions of Square sellers use the Square App Marketplace to discover and install apps they rely on daily to run their businesses. And the way you get your app there is by becoming a Square App partner. Let me tell you how this works. As a Square App partner, you can offer and monetize your apps directly to Square sellers in the app marketplace to millions of sellers. You can leverage the Square platform to build robust e-commerce websites, smart payment integrations, and custom solutions for millions of businesses. And here's the best part. You get to keep 100% of revenue while you grow. Square collects a 0% cut from your sales for the first year or your first 100 Square referred sellers. That way you can focus on building and growing your Square customer base, and you get to set your own pricing models. You also get a ton of support from Square. You get access to Square's technical team using Slack. You get insights into the performance of your app on the app marketplace. And of course, you get direct access to new product launches. And all this begins at changelog.com/square. Again, changelog.com/square.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. We record live on Tuesdays at 3 p.m. U.S. Eastern Time. Subscribe at youtube.com/changelog so you don't miss it. And don't forget to follow the show on Twitter at GoTimeFM. Special thanks to our partners at Fastly for shipping our shows super fast to wherever you listen. Check them out at fastly.com. Okay, here we go.
Welcome, Gophers and wonderful listeners out there. I'm your host, Chris Brando, and today on Go Time, we are going to be taking up one of our wonderful audience members' suggestions for a topic. So Thomas Eckert sent in an inquiry for us to talk about utility functions and code that we have in Go, and how we can organize that, where we should put it, and in general, what should we do with that code. And today I am joined by my wonderful co-host, Johnny Borsico. How are you doing today, Johnny?
I've been better, but I'm, getting better.
It's always good to hear. We appreciate you being here. And we're also joined by a now reoccurring guest, Ian Lopshire. How are you today, Ian?
I'm doing great.
Awesome.
Yeah, happy to be here again.
Fantastic. So I'm sure that we're gonna get straight into the meta, since both Johnny and I are on this podcast today. But I guess we can start with something kind of high level. So I guess I can read the actual suggestion, and then I have something I want to prompt us to start with. But basically, Thomas wrote in and asked, there are a lot of utility functions that I end up writing myself in Go. These are the kind of functions that get asked about on Stack Overflow and met with a response of, this is trivial to implement, do it yourself. For example, the contains slice, string of slice, value slice bool, which is just a regular contains function for an item in a slice, to determine if a slice of strings contains a particular value. Where should I be putting these functions? I usually end up with a junk drawer package of functions, like my own standard library, or I define them one-off within a file or function. How do I organize the code that isn't in my business logic, but also isn't in the standard library? Additionally, how might this change given generics being introduced to the language? Could we get a generics contains function? Should we? So the question I wanted to start off, I guess, basically, have you guys run into this before? Have you had the struggle of, I have this code that's somewhat generic, somewhat reused. Where should I put it? I guess, Johnny, you wanna start off?
Yeah, I can start off. I think we've had various conversations that touch on this topic on the podcast before. And I think oftentimes, I think those of us that are sort of experienced with the language sort of typically settle on the sort of rule of three kind of thing. For me personally, I don't consider something reusable unless I've actually reused it, meaning that I don't try to sort of preempt the process of sort of prematurely, trying to make something reusable, even if I have a hunch that it is going to be reusable, right? So to sort of piggyback off of the suggester's sort of explanation of like utility functions and things like that, like contains, whatever it is, these things on their face seems like, yeah, that should be a reusable thing. But for me, like until I've seen something at least 3 times, I don't have enough data to understand all the edge cases, to understand the variety of ways a particular piece of functionality or even a domain within my application, within my ecosystem, how that's going to be reused. So I don't consider anything sort of reusable unless I've actually reused it a few times.
Yeah, Ian, what are your thoughts on that?
Yeah, I mean, I definitely agree with that kind of rule of 3 idea. I would much rather copy and paste code multiple times than like try to make a abstract version that like is just bad. Like, it's so much easier to add an abstraction later than it is to take one away. So I'd much rather just copy and paste.
Okay. Yeah. No, I definitely agree with that too. You have to, and this is something we can get into a little bit later, but I think sometimes people try and over dry their code where it's like, oh no, I've written this once. I have to figure out how to like never write these exact same lines ever again and like put them somewhere useful. So yeah, I think that's definitely, I definitely agree with you on that rule of 3 there. So I guess like on that as well, let's say that you do figure out that you have something that, you've used 3, 4, 5 times, the code's very similar. What other heuristics do you use to figure out like, okay, should I just be copying and pasting this around? Kind of as the Go proverb says, a little copy is better than a little dependency. Or like at what point do you decide, okay, I need to like put this somewhere that is reusable? And I guess like, there's obviously reusable within the same code base, but then maybe microservices reusable between code bases. How do you start to figure out where those lines are?
I have a fun heuristic for this. If I can think of a good package name for it that like makes sense, like I think that means it's reusable enough that I should probably break it into a package. But if it's going to be like this package that's like 4 words long, I'm just not going to. I'm going to just put it where I need it.
Mine is more of a sort of a, why do I think I need to make this reusable? So there's a reuse. I think you hinted at this, Chris. There's a reuse of basically within the same code base. There's also reuse within multiple projects, right? So I could extract away a package and make that reusable. But interestingly enough, I don't know whether maybe it's the problem domains I work in these days. But I think this could be considered a dirty little secret. But I try not to create packages, even if I happen to reuse them within the same code base. Very rarely am I sort of abstracting a package and making it sort of reusable across projects, right? So I tend to sort of, if I have enough sort of data to make something like generic, not generic in the sense of the feature, but like generic in terms of reusability, I'll try to make that sort of happen within the context of the particular application or service that I'm working in, because I don't want to create a standalone package that other teams are going to depend on. And now I'm on the hook for keeping that thing up to date, right? I'm on the hook for sort of managing and maintaining that thing. So I'd rather keep reusable chunks of stuff in my own project, because I know the moment I make it reusable by other teams, right, the responsibility scope for that code has just grown for me. And honestly, perhaps this is an unpopular opinion, or perhaps, I'm just getting to that point in my career where I'm just not looking for more work to do. I just, I'm just keeping it, constrained within my projects. And, like if somebody, happens to know my project, whatever I'm working on, and they come and say, oh, can I reuse that? I'm like, yeah, sure. Just literally copy the code. But, I'm not making this into a separate package for you. Just copy the code. That's fine.
I'll mirror that. Like, I'm a fan of the like internal folder. Like, it's not even allowing you to use this.
I think in this case, using the internal folder to be like, no, I know you might want to use this thing, but like, please don't. Like, please don't touch this thing. But I've also seen the other extreme where it's just like, okay, no, we're just going to assume that by default. And everything's going to go under the internal package. And that's just going to be like the top level thing in our Go code base. And like maybe there's a couple things on the outside. Do the two of you kind of agree with that? Or do you think it should be just like, okay, no, I've made an explicit decision. This is something that perhaps someone might want to use. I'm going to mark it as like, no, don't depend on this because I don't want to maintain it? Or are you on the side of like, no, it's okay to just kind of put everything under internal and pull things out as necessary?
I don't have a habit of doing that. What I do have a habit of is just not exporting anything I don't have to. so they're not going to be able to get to it anyways. But I'm known to put like kind of very general packages in internal just because they look appetizing to use externally.
Perhaps my other dirty little secret, I don't use internal a ton. I think even then, like, I've heard some folks basically approach projects with basically saying, well, start with internal, and then if you need to, take things out. I don't take that approach. I tend to sort of reason about the stuff I'm working on, in terms of sort of a domain-driven design and what is it that I'm working on, and then I worry about sort of shuffling files around, and then I worry about packaging. I will literally have everything into a single at sort of the root level of the project before I even start to create folders, creating packages and things. So because I don't know what I don't know yet, so I literally have everything in the same sort of a top level sort of package. And if I know I'm creating executables, one thing I absolutely do is I create a CMD folder followed by another subfolder to represent the name of the binary that I'm going to build. At the start, that is literally the extent of my organization. Back in the very early days, I started following this pattern of putting things in a PKG folder and all that sort of jazz. And honestly, I think that's an anti-pattern at this point. Like, you don't need a PKG folder. And if you happen to work on a project you've inherited that has one, fine, so be it. But you don't need these things, right? So I really rely on sort of a complete understanding of the problem I'm solving. I'll even go as far as to actually have in my CMD / whatever name folder I need, I'll have my main .go in there. I'll have other Go files in there. Literally, I'll have everything that I need to make this binary, right? Especially if at the start of a project, I have everything I need to make this binary build and sort of do a proof of concept, whatever it is. Literally, I'm not thinking about packaging or extracting or moving anything. I just have everything in that folder. Then if another folder underneath my CMD now needs some of that same functionality, then I'm like, okay, well, I have multiple binaries that are using these constructs and things. Maybe now it's time to start extracting some things away from the first folder and move that up a level underneath the sort of the main repository, and then basically start referencing these things from those subfolders and from those executables. It's all incremental, right? I'm not. Even if I've built this kind of project before, I know I kind of have a sense of where the seams are. I know what I'm gonna do, right? I have the discipline, or I've developed the discipline to not jump the gun on that. Like, I really need to start seeing the edges of this service. And sometimes I will be completely happy with a bunch of stuff being in my in the executables folder, right? Because I don't yet have a reason to move these things out, right? So again, that whole, basically, you don't know what you don't know yet, right? And sometimes, you build these projects and they might be proof of concepts and they might be things that don't end up going to production. Why am I going to expend all this brain energy trying to make all these reusable things and abstractions and things? Now I'm writing way more code than I need to, trying to avert, cyclical dependencies and trying to do all the that's just too much work. Again, I think I'm getting to my grumpy old man stage of Go development, but I'm just not trying to do more than I need to.
Right. So you're kind of, the way you follow things is like, start with just one package. Maybe it is even just like the main package. And then as you have reasons to start pulling things out, that's when you start pulling things out. Which I would also say is a very good way to avoid having people import your code, because if it's in main, they can.
You can't import main, right?
Like, stay off my lawn. You can't touch any of my stuff. So I wonder, does that change when you go from building a application that's going to run as like a microservice or something, when you shift from that to writing a library is going to be consumed by other people? Do you still take the same single package approach, or do you start at that point trying to like predefine where things might be laid out?
This This episode is brought to you by our friends at SourceGraph. They recently launched a new feature called Code Insights. Now you can track what really matters to you and your team in your code base, transform your code into a queryable database to create customizable visual dashboards in seconds. Here's how engineering teams are using Code Insights. They can track migrations, adoption, and deprecation across the code base. They can detect and track versions of languages or packages. They can ensure the removal of security vulnerabilities like Log4j. They can understand code by team, track code smells and health, and visualize configurations and services. Here's what the engineering manager at Prezi has to say about this new feature. Quote, as we've grown, so has a need to better track and communicate our progress and our goals across the engineering team and the broader company. With Code Insights, our data and migration tracking is accurate across our entire code base, and our engineers and our managers can shift out of manual spreadsheets and spend more time working on code, end quote. The next step is to see how other teams are using this awesome feature. Head to about.sourcegraph.com/code-insights. This link will be in the show notes. Again, about.sourcegraph.com/code-insights.
I pull a page from Ian's book and basically saying, hey, the I don't export anything I don't want you to use, right? So like even then I might not have an internal folder inside, even if it's basically a package that's designed to be used as a library, because the moment you make something a library, again, going back to that scope of responsibility, right? It's not just a code you're now putting out there. You've basically taken on the responsibility, right? If you're a good maintainer, of maintaining this thing and keeping it up to date. And who knows, there might be security things you need to do for the package, depending on what the problem and domain you're in. Like you have taken on the responsibility of keeping this thing up to date, right? For the users of your package, right? So I will never expose anything prematurely. Everything will be unexported until I have a reason to export it. I used to have a bad habit of exporting interfaces out of my libraries, right? To say, oh yeah, like you can use this public interface, this exported interface, so you can know what to pass in when you call in, some functionality into my package, whatever it is. Here's some nice interfaces to help you out with that. Like I don't do that anymore. Like right now, I rarely, if ever, export an interface, right, from my library, because you can actually, in your own code, you can create, single method interfaces, whatever you need. You can create local to your code interfaces for whatever you need. Like I don't need to give you exported interfaces for you to know how to use my library. As long as I clearly document the exported functions, as long as they make sense, the naming of things, that's still very much important, whether it's a library or an executable. I make sure that the naming and documentation are up to snuff and never expose more than I need to. And even the unexported stuff, I will document them as if I'm going to export them, because who knows, I may end up exporting them, right? There's a way using GoDoc you can actually show unexported documentation for functions and stuff. So, when I need to actually on the command line see what, unexported functionality documentation is, I can actually do that, right? So things are documented as if I'm going to make them available for people to use, but I don't do that unless I absolutely need to. So I keep my package's surface area for interaction very, very small, right? Only doing just what it needs, never more than that.
Yeah, Ian, what do you think about that?
I mean, it's hard to disagree with anything that was just said there. I think that pattern of just starting with one bit, like one package, one thing, like even if you're just adding a feature, like I like to start in one place and do that proof of concept. And it should be that iterative approach, right? Where you're getting it working, and then we can go back and organize if we need to. But avoiding that premature like organization and abstraction and all of that, I think is probably the most important part of the job. Like one of the most important parts of the job.
Yeah, sounds like a key thing to building maintainable software as well. So that's
wouldn't you know?
I mean, I don't think I declared this as one of our maintenance series episodes, our mini, but now max maintenance series. I wonder if we can just follow like Apple's naming his. So this would be like Pro, and then we could have Max, and we can have Ultra when the series gets longer and longer. So I guess this is the Pro maintenance series now, soon to become Max when we level it up some more. But yeah, I from what you're saying, Johnny, and when you're saying Ian, it sounds like these are also like good strategies to kind of build more maintainable software in for us in the future as well. As once you do export something, you can never really take that back at the end of the day. It's kind of there forever, which, kind of going back to what we said in the beginning of the show, sounds, copying something around. Okay, there's 2 copies of this thing now. Now you don't have this kind of piece of code there that 2 things are vying for control of at the end of the day, which I think is, super important. But let's say that we have figured out that like, okay, here's some code that really is generic at the end of the day. It really is just like, okay, just like copying it and pasting it all over the place, and I'm changing like the changes I make, I can just run a copy and replace or find and replace in my code editor, just changing some names. But aside from that, the code is truly like copy pastable. At what point, or I guess in what way, do you then take that code and make it so that it's not so much copy and pasting? Or do you just say, well, this code is small enough and I don't want to make it into a library I have to support, so I do just continue copy and pasting it forever? Or do you do something else, kind of make it less arduous over time?
I think a good example here is like the AWS.string, where we're taking a string and returning a pointer to it. And I have that all like sprinkled throughout the code base. It might be a struct that I'm trying to do. And before generics, I think the place for those were just where you needed them. But I think that's like one of the prime candidates for like a generic package where we can just take a type and return a pointer to it.
I'm kind of surprised there isn't a package that just does that someone maintains out there. Or maybe there is and I just don't know. I mean, I think it'd be hard to come up with a name for it, but
there's one just called Pointer, PTR.
Oh, well, that's a good name. So following your rule, Ian, that makes sense.
Exactly.
You see, for me, I consider things like that to be extraneous. Like, again, I'm going to be that, old man pointing at the cloud, right? I'm like, okay, if I need a pointer to something, I will use the language proper to make a pointer to something. Yeah, it might be a little more verbose, might not be a nice one-liner from a package or whatever it is. But again, not saying it's a bad thing. It's just style or desire for bringing in third-party dependencies. I mean, I'm very shy when it comes to bringing in third-party dependencies into my code base. Very, very shy. Because again, that whole sort of responsibility model, right, for that package, I'm more likely to look favorably upon a package that I'm evaluating to bring into my code base if it is actively maintained, right, if there's activity on the code base. And obviously, certainly for sort of a very specific kinds of functionality, where I'm not going to reinvent wheels, right? So again, basically not doing more. A lot of times I'm not doing more work than I need to, kind of thing. So if I'm really going to be aggressively using a package to do things, these specialized kind of work, yes, I will find a suitable third-party library out there, and of those, I will evaluate them to say, okay, which one is documented well enough, which one is maintained actively, which one is referenced by other things, like the PKG, pkg.go.dev now shows you, or maybe has always shown you, how many packages import whatever package you're looking at, right? So you can see how well used that particular package is, right? And that way, folks have worked out, the bugs and issues and whatnot. If it's been imported and it's heavily used, then a lot of people have run into the potential issues you might have run into, right? So all these things factor into the selection process for bringing in a third-party dependency. So to me, it's a matter of I've been around the block long enough to understand the cost, right, of abstractions, to understand the cost of bringing in third parties, to take away perhaps some labor you might have had to do on your own, to perhaps write things the long way and the more verbose way, right? So everything is a trade-off, everything, right? So it depends on what cost are you willing to bear today, and also in the future, as your software, especially if it goes into production and you have to end up having to maintain it for the long term, are you willing to bear the cost of all these third-party dependencies, of all the abstractions that you're introducing, even the ones you introduce into your own code base? Like I've seen very large projects that basically have some abstractions that no longer hold water today. Perhaps back then when they were introduced made total sense. But today it's like people, you have little notes, little side notes on these things. Well, don't use that anymore, right? Or deprecated. Use this thing instead, right? Like I'm like every time I see those, I'm like, yep, I know exactly how this one came to be. There's some abstractions going on. We thought we were going to do this, but business changed, and now we're doing this instead, right? So yeah. I think it's all lessons learned, really, at this point.
And part of me wonders if this is like a shift from the pendulum swinging. Like I know when I first started my career, the kind of ethos for everything, I think partially because it was so difficult to get dependencies, was like, build stuff yourself. And I think I joined the industry right as we were swinging away from what was deemed kind of negatively as like not invented here syndrome toward the proudly found elsewhere, which I think is like the positive spin, obviously trying to get toward one side of those things. But I kind of wonder if like, what you're saying, Johnny, is like the kind of evolution that's happened from us swinging a little too far to the other side of proudly found elsewhere, where we have these problems where doing this type of evaluation on external dependencies, to do it properly takes a lot of time and effort and energy. And it seems like the rate at which we keep pulling in dependencies, we're not really doing that at the end of the day, right? It's like, there's the famous Node.js bugs, or someone deletes a package and then the entire ecosystem just breaks for a long period of time. And, even more recently, the different types of people sneaking malware into their own packages to get people to stop using them or because they're mad about something. Just all sorts of problems that exist because we depend on code that isn't our own for a little bit too much stuff. So I wonder if either of you, do you kind of agree with that like, we have swung a little bit too far? Or do you think it's something else that is kind of like, okay, well, maybe we should be rethinking our dependencies? Or is it just like my perspective here in that like, I've seen this change over my career and it's just like, okay, well, if you'd started 10 years earlier, you would have seen the same change over the course of those first 10 years or whatever.
I think we're kind of lucky with Go because we have such a good standard library. A lot of what you would have to like kind of import from a third party before, you just don't need to. So like, I think in Go, we might have veered towards the kind of just rewrite it and don't import an dependency, but I think that's okay because we have such a good like standard library. Obviously there are things not in the library, but yeah, I don't know where I was going with that one.
I can add some flavor. I'm not sure if it's so much as sort of the pendulum swinging back and forth, and it very well could be, depending on where you're sitting. But I think generally speaking, whether it be with Go or Ruby or Rust or whatever it is, there's a reason why you have things like best practice. You need bad practice or you need not so good practice in order to have best practice, right? So that means it takes a whole lot of people doing a whole lot of things, sometimes smart, sometimes not so smart, right? In order to see enough patterns of usage and start to recognize, okay, over time. And that's the critical element here, time. To understand, well, if I engineer my piece of software this way, right, I am least likely to run into these kinds of problems that we've seen occur again and again and again and again, right? Hence, best practice, right? So you need the time element as sort of a key ingredient in understanding sort of that pendulum, if you will, right? To understand where are we now, right? Given this context, and how is it likely to change when things swing back around? And really, as you mature as an engineer, I think that the best thing you can do for yourself is expose yourself to enough patterns that you can recognize which one is applicable where and when. There's never going to be the perfect solution. That such a thing doesn't exist. It's only what are the trade-offs you're making today, right? Given the information you know now, with a hope, right, of having maintainable, well-engineered software into the future. It's all, you're just hedging. That's all you're doing, right? The only time can tell you, right? And even if the pendulum seems to be swinging, oh, this is the new hotness, organize your code this way, or this is the new hotness. I mean, I remember when, again, going back to that whole PKG thing, I remember that when that was the new hotness. I mean, everybody was putting PKG into every darn, Go package. Heck, I did it, right? Because I was just going along with the flow. I'm like, oh yeah, some of the most, well-respected people in the community are using PKG and then blah, blah, blah. I'm like, okay, I'm going to start doing that too. I literally cargo culted the thing into my own Go. I didn't even know why I was doing it. I was like, oh yeah, so-and-so does it. that they must know something I don't, right? But only over time do you realize, okay, why am I doing this? Right? You start asking yourself, why am I doing this? Right? Because I read a blog post somewhere where somebody had a specific set of concerns and constraints, and they said this was the right way. And then now all of a sudden I'm using their solution to solve a problem I do not have. What kind of sense does that make? Right? So when I see blog posts around, package structure and things like that, and there are a few well-written ones, I always try to understand what problem are you solving, right? Some of the best blog posts on the matter, I think John has written one as well that we'll put in the show notes. I've also seen some well-written ones from Ben Johnson of BoltDB fame. I've also seen some from Bill Kennedy, right? People who know their stuff, right? But not all of their approaches and solutions works in all of my use cases, right? So you could say, well, Ben said do this, so all my projects now are going to look like this. Well, no. What problem, right, is Ben trying to solve in his blog post? What problem is John trying to solve in his blog? So you have to take context, right, into account, right? And you have to use time as your friend, as an engineer, to learn to recognize patterns. Say, you know what will work best here? I'm not a big fan of the MVC, but you know what? Organizing things as if it was a sort of a Rails project, like having models, views, controllers, or whatever folders, right? Instead of arranging things, as a sort of domain-driven way, right? This model may be better in this particular case because I'm building a CRUD app than this model here, which is more of a business, vertical, a very specific service that I need to build, or a third-party package that I need to build, right, for other teams to use. So again, the context is going to be what drives you towards one or the other, but you're not going to know that you have options, right? Unless you educate yourself, unless you add time to the mix to learn to recognize patterns.
Yeah, no, I think that's spot on. I wonder too, I wonder if this is like part of our problem with best practices, and the way that a lot of people conceptualize them right now is that it's kind of like, sometimes it's just kind of like, oh, no, just do this thing because, like, as you said, like, oh, these important people are saying that we should do them, or these important people are saying that this is the way that we should make these things happen. I feel like Go is kind of unique in this way too, where when I look at things like the idioms we have, or even things like Go proverbs, I've never seen them as things where it's just like, no, shut up and just accept that's true. I feel like they kind of call out to you to like, no, sit down and actually think about this thing a little bit more thoroughly and make sure you actually understand what it's saying. Because even at face value, you kind of like, it like forces you into that kind of thought process. And I wonder if that's like a hallmark of like what a good best practice is, this thing that's not simple on its face. Like, I think don't repeat yourself is one of those things that is like sort of a best practice, but it doesn't have that same type of impetus for you to kind of dig a little bit beneath that to make sure you understand it a bit. Like, I feel like it's so catchy that we just kind of repeat it all of the time without understanding, maybe its genesis at the end of the day. Would you agree with that, Johnny?
We have these sort of sayings, these best practices, right, that we've accumulated over years of practice, right? The software engineering practice, right? Don't repeat yourself, right, is a good one. Like, dry all the things all the time. Man, I violate that rule every single day I write Go code. I'm like, don't repeat. Yeah, sure. Yeah, And in most circumstances, generally that's, you don't want to repeat yourself because you have to understand the intent behind that saying. The intent is, well, don't repeat the same functionality because now when you need to modify it here, right, you also need to modify it there, and there, right? But if I never have a there, and there, right, and only have here, why do I care about dry? Or if I only repeat it a couple of times or 3 times, like once I hit, again, that rule of 3, once I hit it 3 times, then I might think, okay, is it worth refactoring? Okay, maybe the 4th time, it comes up. Yeah, maybe. Yeah, maybe I'll create some abstractions and sort of reuse it, within that code base. But we can't go into projects with sort of this Bible of sayings, be it Go proverbs or, the Gang of 4 book or domain-driven design, or what. We can't go into our projects with these seminal works and expect, well, I'm just going to throw these books at the problem. Right? Honestly, especially at the early days of a project, I'm never concerned about design. Again, maybe dirty little secret of mine, but I'm never concerned about design. I'm never concerned about reusability. I'm never concerned about abstractions. It's too early. It's too early. Like, the only thing I know is, my manager came to me and says, well, we need a service to take this data from point A to point B. That's all the requirements I have. Now I'm like, digging through docs of projects, asking, other team members, hey, have you seen this thing? Do you know what this thing is? Like, I'm literally researching what the heck it is I've just been asked to do. Like, I have zero idea what it is I'm about to build. So what makes me think I know how to design this solution? Don't get me wrong. Like, I'm not going to approach it as a novice. I'm not going to be sort of shipping something that is not of high quality. The code will be high quality, but the code will not be concerned about design and reusability and architecture and all that stuff. That's the stuff that I do when I know I'm going to put it out in the world. If it's a package that's going to be reused by teams, then I sit down after I've solved the problem. Then I sit down, I worry about design and architecture and rearranging and putting things in the right places, right? If I'm worried about sort of performance, then I'm going to take my proof of concept and then, okay, I'm going to run that, through PPROF and saying, okay, well, like where do I have unnecessary, Go routines, spinning up and doing things? Where do I have waste, right? Where do I have some allocations that I could sort of maybe reduce, right? Only then do I have these concerns, but we can't go into projects with these, granted, great ideas that have come over time. We'll be in analysis paralysis like for days, before you even try to solve a single problem. Like, it's maddening to think that we can just throw all these best practices right at every problem every time, and then we wonder why we can't move fast because we're just stuck designing.
Or you wind up with factories or other things. So I just took the whole Gang of Four book and started applying it all over my code base, and now my code is correct, right? These are all the best practices and the patterns we should be following. Yeah, Ian, do you have anything you wanna add to that?
I just want to kind of extract something from what Johnny was saying. I think what's underlying everything he said is thinking, what problem am I solving here? Like, you get your proof of concept, and what's my next step? Is it making this available to another team? I'm gonna make my decisions based on that. If it's performance, I'll make my decisions based on that. So I think no matter what your best practice or proverb is, like that underlying why is what you have to think about.
This episode is brought to you by our friends at Fire Hydrant. Fire Hydrant is the reliability platform for every developer. Incidents impact everyone, not just SREs. Fire Hydrant gives teams the tools to maintain service catalogs, respond to incidents, communicate through status pages, and learn with retrospectives. What would normally be manual, error-prone tasks across the entire spectrum of responding to an incident, this can all be automated in every way with Fire Hydrant. Fire Hydrant gives you incident tooling to manage incidents of any type with any severity with consistency. You can declare and mitigate incidents all inside Slack. Service catalogs allow service owners to improve operational maturity and document all your deploys in your service catalog. Incident analytics let extract meaningful insights about your reliability over any facet of your incident or the people who respond to them. And at the heart of it all, incident runbooks, they let you create custom automation rules to convert manual tasks into automated, reliable, repeatable sequences that run when you want. Create Slack channels, Jira tickets, Zoom bridges instantly after declaring an incident. Now your processes can be consistent and automatic. Try Fire Hydrant free for 14 days. Get access to every feature, no credit card required. Get started at firehydrant.io. Again, firehydrant.io. And by SignalWire. SignalWire offers APIs, SDKs, and edge networks around the world for building the realest real-time video and video communication apps with less than 50 milliseconds of latency. They use WebSockets to deliver 300% lower latency than APIs built on REST, making it ideal for apps where every millisecond and responsiveness makes a difference, like apps that need instant natural language understanding, real-time machine vision, or large-scale video and audio conferencing. Here's what makes them different. They use MCU, multi-point control unit, that mixes all video and all audio feeds on the server side and then distributes a single unified stream back to every participant That way, every participant in the apps you ship experience the same video and the same audio. Your apps have none of the awkward audio effects, obvious lag, and jumpy video. It's all smooth, great UX, creating a more lifelike virtual experience without compromising audio or the video quality. Head to signalwire.com/video, mention GoTime to receive an extra 5,000 video minutes. Again, go to signalwire.com/video and remember to mention GoTime.
Part of what you were saying, Johnny, reminds me of this thing I've been thinking about for like the past week. I don't know why I started thinking about it, but just kind of like popped into my head. Our industry is very good at taking like those early prototypes and just kind of shoving them into production, right? Of just doing, okay, we're gonna make an MVP, and then it's going to production, and we're gonna rewrite that code later, and then like later never actually comes until it's like so terrible that we are like, okay, we gotta throw out this whole project and then do greenfield, even though greenfield's really brownfield, but we gotta just rebuild the entire thing from scratch. And the thing I was kind of thinking about was like, you know, if you're gonna go build an actual product at the end of the day, whether it's, you know, a car or a widget or whatever, there's like the prototype version of it that you build, the proof of concept that's like, okay, we can do this. But then you have to go and kind of have like a production process, like a manufacturing process, where a lot of those elements of that thing might change. The overall idea of it stays the same, right? You're still producing a car or a widget or something, but like the way that that thing gets produced is significantly altered in order to make it so that you can mass produce it, so you can, you know, put it on a production line and churn those out so people can buy them. And it feels like we don't really have an equivalent of that in software engineering, right? It feels like we're missing that step of, okay, we wrote this thing, we built this thing as the prototype. Now we know our idea works. Okay, put that over there. We can reference that. Now we're going to go rebuild the new thing. And I kind of wonder, do you guys, do you feel that, yeah, we are missing that kind of step? Or do you think like, okay, well, we don't really need that sort of step because we're not, you know, making a million cars at the end of the day. We're making like a set of features. So that's a completely different thing. And that doesn't really fit the same analogy. What do you guys think about that kind of analogy I just made there?
So the car industry, I'm not from the car industry, so I'm just looking at it from as an outsider here. But from what I've noticed, the car industry, they'll have these shows, right, where they have those sort of beautiful, futuristic looking designs of automobiles. And you're looking at the thing, you're like, man, this thing's like, why don't they actually build these things and put them on the road? But these concepts, right, these concept vehicles are, their purpose is not necessarily to sort of provide a proof of concept, even though there's concept in the name, but it's not to provide a proof of concept for a practical version of the thing. The part of the reason you have these very futuristic looking, not really going to go to production sort of looking vehicles is that they're part of marketing. They're beautiful to look at. They're catchy. They demand attention. You look at them, it's like, wow, I would love to sit in this thing and ride around with this all glass vehicle or whatever. It's like whatever the main appeal is, right? But these things, they know these things aren't going to go to production. One, because there are lots of constraints, including government requirements that certain vehicles, you know, have a certain, you know, mileage or safety things associated with it. Like, there's a bunch of constraints that are going to force this beautiful futuristic looking vehicle to being something lesser than the concept itself, right? But that doesn't mean there's no need for the concept, but its purpose, right, is not to give you something that you can sort of take to production, right? Its purpose is to get people excited about something. So if we take that exact same analogy and bring it into our world as software engineers, the purpose of a proof of concept is to have something that proves an idea is possible. It is feasible, right? The problem we have, right, and this is something I've noticed and been a part of, unfortunately, many times over my career, is that the proof of concept, somebody will see it, and be it, you know, a service or a front end or whatever it is, the business will see it or somebody will see it and be like, oh, you know what, that's good enough. Let's put that in production.
Right.
Right. And all of a sudden you're an engineer, you're like, you put both hands over your head. You're like, no, this is not what I wanted. Right. This is not what this is meant to do. Right. And you argue and you fight and you say, hey, like, really, we shouldn't do this. This is not ready for put. Like, you make all the arguments in all the cases. And at the end of the day, the thing that you didn't think was going to be production worthy finds its way in some version of production. So now we get shy. We become shy about the possibility of that happening again. If it's happened to you more than a couple of times, your proof of concepts start looking less like proof of concepts, and they start looking like more like possibly, maybe, might go to production versions of a proof of concept. Right? You spend the time on design, you spend the time on packaging, you spend the time on folderization and making sure, if a developer, stumbles on your code, you're not going to be embarrassed. You spend your time sort of tweaking, right, and massaging this thing when you could spend the time actually proving that a concept, that an idea is possible. So I think it's an unfortunate place that we're in with proof of concepts, but it's one that I think we've been driven to this state where we as developers are shy, right? We're afraid that our proof of concepts, that our throwaway, what's meant to be throwaway code, will actually end up being thrown into production instead.
Right. And we also have the engineers that, they go through, they make that proof of concept, and business asks, how long till we can put it? And they're like, oh, it's like 80% done. And like, okay, that might actually be technically true, but that last 20% is like the most difficult part of it. So It's not really there. So I think there's a little bit of both playing in there as well. Some people are very like, okay, no, we got to we're only going to do this once, so we got to do it the right way. And you have a whole bunch of other people that are like, no, we just need to build it and go. Ian, I'd be curious to hear your thoughts on analogy and what Johnny said and all of that as well.
Yeah, so on the analogy side, I think the equivalent of those production cars, those sample cars you see at the big shows are like the Dribble UI mock-ups, I think that's that's where those exist. But as far as proof of concepts, I'm at the point where I kind of struggle knowing when a proof of concept is even necessary. Like when you're just building a new feature or something, a lot of times it's possible. So what do you think of that? Do you think proof of concepts are always necessary, or do you think it's...
If you've never done a thing before, for example, a few years ago, I was asked to look into this whole serverless thing. Is this going to work for our workloads and things like that? And I was given a particular problem to solve, and then it says, well, can we do it without EC2 instances? I was like, well, I don't know. It depends. How long is the process that you're gonna? How long is the workload? Because at the time I think there was a 5-minute time limit to Lambdas, or 15 minutes, whatever that was, whatever the initial limit was. I'm like, well, if your workload is gonna take longer than that time, then no, you shouldn't use serverless. You shouldn't use Lambdas and things. And what if we break it apart? What if we do smaller things, a bunch of small things, the best practice at the time says. What if you just make a bunch of different Lambdas, or invoke the same thing, put it in a pipeline, invoke the same Lambda multiple times, right? You can scale it infinitely according to the AWS marketing. Just do that instead. I'm like, well, now we need to orchestrate. Right. And then at the time, AWS had step functions, which pretty closely followed Lambdas, or at least the use of step functions for Lambdas basically became a thing. And then orchestration, rather than have one Lambda call another and then run the risk of one function waiting on another and timing out the whole thing. And now you can use step functions, and you can have ASL, Amazon State Language, whatever it is. You can write some of that YAML or whatever, and basically orchestrate all your things, right? These were things that we had never done before, right? So in that case, I'm definitely doing a proof of concept, because I don't know what I don't know. I need to understand the characteristics of the platform, what it offers. I need to understand what all the knobs are, right, for the service that I'm supposed to be using. So there's a lot there that I need to do, right? So this is kind of an example that goes at sort of a perhaps the infrastructure level to some code level, obviously, because the programming language that you use is going to have an impact on your serverless stuff, no doubt. So if I'm working with a Java project because of the JVM, and I know that needs to be booted up, whatever it is, I'm going to take that into consideration, right? If you tell me to build something with Java and Lambda, as opposed to if you tell me to build something with Go and Lambda, then I know I'm not going to suffer, the costs that of a JVM. So again, all these sort of trade-offs that you're looking at, right? So again, the more you don't know about the kind of problem you're solving, the more I think you need a proof of concept. And that goes, this was an example at the sort of infra level, but if somebody says, hey, decode this data stream, I've never seen that before, right? It's not like anything I've ever seen. So I might need to do a proof of concept to sort of understand what I'm doing. So I think it's going to depend. To your point, Ian, I think it's just something that we don't naturally gravitate to at first, because maybe it's hubris. I don't know. Maybe we think we can just start working and we'll figure it out. You know, we'll bang our head against it. We'll just figure it out, and then whatever we come up with, ship it to production.
I guess I would say that I think if I think about this from a writer's perspective, I would say you should always do prototyping or proof of concept. And I think that way because it's like if I think about how I generally tend to write code versus how I would ideally write something. If I was going to write something, I'd sit down and I'd do some drafting or some basic sketching of an idea. But like, I'm not going to try and edit as I write, right? I'm not going to try and copy it as I write or even like try and make the thing fit together properly because that's going to like slow down the whole process overall. And it might even prevent me from getting to the goal I want because I've taken up so much time doing it. So I'm just going to like rough out the idea quick and dirty, get all of the parts of it on page, and then start the editing process and refining it and trying to get it, you know, all shiny to send out to production or, you know, publication. And I feel like that is something we should do with code. And I feel like this is something that I would love to see more engineers doing is like, okay, I'm just going to like rough out the idea quick and dirty, like maybe not even have that many tests or anything. Just like, does this thing work for basically like even the smallest of features that we want to do, and then have the solid idea of what we want to create and then go back and then rewrite it and redraft it and like put it into the structure and format that we want. Because I think not doing those types of prototypes means that we're kind of cutting down on the number of iterations or the space that we can think of an idea, right? Like, I know for me, if I go to write something and it's like, okay, well, I know this is going to have to go to production and I spend a bunch of time having to write tests to like make sure this small part of it works, kind of kills my creativity at the end of the day. I'm kind of like, man, I got to think about all of this stuff. And it kind of knocks me into a different stream of thought than the stream of thought I was using when I was prototyping this feature and was kind of figuring out how to put this thing together. So that to me seems like one of the failures we've had as an industry is that we don't encourage people to prototype always. And I think that the reason we don't do it is because I think at one level we kind of like hold prototyping up on this like pedestal, and it's like this fun thing that you get to do. It's like it's what you do when you go play with new technologies. It's not something you do when you're just going to implement some boring business feature. I think it's that mixed with a little bit of hubris too. It's like, well, this thing is so simple. Of course, we can just write it correct the first time. Like there is so few lines of code that I've written right the first time that I've actually came back a week later and been like, no, that was the right thing. Actually, I don't think I've ever written code where it's like I wrote it once and that was it. And then I came back and looked at it and didn't think it was like just like every time it's like, no, this could be so much better. And I think that's like a practice that maybe we should start introducing into the way we do things of just, you know, ease the business into it, obviously, but be like, no, we have to actually like write the code rough and dirty first, get all the little, like the small high level parts correct. And then we'll go and productionize the code. Then we'll go and add all the testing and the monitoring and all of the logging and all of this other stuff that has to go around it to make it spick and span, and obviously documentation too. The amount of code I see in prod that doesn't have a line of documentation, or they add like the function name or the type name and then ... to get around the linter, or, you know, whatever thing they can do. So don't have to write. And it's like, I think that part of that is because we don't sit down and we're not like, oh, no, we have to like actually prototype this first, and then there's this other series of steps we take to make it productionized.
Yeah, I almost don't think of it as like a proof of concept. I think of it kind of as levels of drafting. Like you said, like, I guess the first draft is like that proof of concept. You know, I'm going to do it quick and dirty and make sure it works. And then we go back and make sure we have observability and all of this. Yeah, I almost think about it more as drafts.
Yeah. So I have to move on to the next segment. But Thomas, if you're listening, I hope that we answered your question. And if we got on a meta rant and didn't, I guess we'll just have to do another episode and try to answer your question. But now it is time for unpopular opinions.
Unpopular opinion. I actually think you should probably leave. Unpopular opinion.
All right. Ian, since you are our guest, do you have an unpopular opinion?
I feel like I never do, but I don't know. I cannot think of a good one.
It doesn't have to be good. It just has to be unpopular.
Give me a minute. Maybe come back.
Okay. I'm sure Johnny has a few. So do you want to share one with us, Johnny?
Sure. I mean, I think I've shared quite a few during this episode. I mean, yeah, if I could maybe summarize some of what I guess I hold most dear these days about, especially around sort of code organization, is don't organize your code, right? In the beginning, you don't know what you're organizing yet. Just get the thing done, right? Solve the problem, and then say, okay, well, what am I trying to achieve in now organizing this code? Am I organizing for readability, maintainability? Am I organizing because it's going to be used by another team or by maybe the open source community? What am I organizing for, right? Obviously, I'm a big fan of domain-driven design. I always, I keep that in the back of my mind. I don't tend to use sort of frameworky things, generating, folders for me and scaffolding. Again, the type of work I do, I have very, very little use for scaffolding and things and frameworks and whatnot. But if these are the kinds of problems you're solving, if you're building CRUD apps for a living and you want to use, frameworks to generate things and put files and generate things for you, put them in the right folder, and for things to wire up properly, you need to put them in a models folder and whatever. I mean, if that's your jam, that's your jam. I'm not, kicking it by any means. But yeah, beyond those use cases, like, man, solve the problem first and then worry about, organizing it, then worry about abstractions, then worry about, what's being used and reused and things. And don't be shy to copy from across projects. Even just don't be afraid to just copy a file here and drop it in your project. Just get things done, just get it done, and then worry about organizing it.
So if you were to write a blog post on how you should organize your Go code, it would just say, don't. Like, by the time you need to organize your code base, you won't need a blog post to tell you how to do it. Like that.
Exactly.
So you just publish that on the changelog blog right now. Yeah, that's just. I mean, I definitely agree with that. I think people do rush way too fast to try and sit down and organize their code bases. I mean, I personally always start with the one file, one package, just put everything in it. And then once it starts making sense to split things up, I start splitting them up. I think that's a nice thing about Go, is that you can have a file that is maybe even 1,000 lines long, and it's still very readable. You can still find things in it. I think the language
Whoa. This is where you and I fork. 1,000 line long file? No, you're not going to have words.
Disagreement. We'll have a whole episode about this. Whether it stays at 1,000 lines is debatable, but I think files are. I'm more okay with people splitting things up into files. I think the thing I like to avoid is people that make 40 files with 20 lines of code in them. Right? There's a middle ground here. If I do write a file that gets to 1,000 lines, then I'm kind of like, okay, this is a little long in the tooth. Let's break this up into pieces. Let's see how we can format this better. So definitely that. But yeah, I definitely think one package to start with, and then go from there. So Ian, did you come up with an unpopular opinion?
I think I did. This might be a repeat, though. I don't know.
Okay.
My unpopular opinion right now is that monoliths are probably the way to go for most companies right now. Like, I think like all these companies going microservices are doing one of those things where microservices are best practice, so we're just going to mindlessly do it and not thinking, why am I doing this?
Wait, we haven't learned from all the case studies of people who went micro and went back to, I guess, macro or monolith or something. A lot of times people think that, yeah, I'm going to adopt microservices because it's cool and trendy and whatnot. And they're realizing that when you go microservices, you're not making just a coding decision. You're also making an operational decision. So your developers, right, while they may have input into the decision to microservice or not to microservice, I think the operational folks, right, the SREs, the people who need to keep this thing running and orchestrate all the things and deploy these things across infrastructure, make your thing into a distributed system that actually cohesively works, right? They need a say into the to microservice or not to microservice decision, because everybody is affected by that. So it's not just a developer writing code and choosing to put a network boundary in between their projects. Everybody needs to go in with both eyes open.
See, we just got to rebrand monoliths into macro services, and that will be the new hotness. And that's how we can get people over macro. It's like, obviously macro services are better because they're bigger, right? Macro. Why would you do something micro when you can do it macro? It's innovation. It's bigger. We want to do bigger. We want to go. All right. So yeah, we'll put the polls up on Twitter and see if your unpopular opinions are actually unpopular. I am curious to see if they are. And as the rule goes, if they're not, you have to come back and try again to be unpopular.
Justify.
And perhaps one day you will be as unpopular as some of my opinions have been, to once again warrant us some negative reviews on Apple Podcasts. If you like the podcast, go and give us a nice review on Apple Podcasts, please. So, but yeah, with that, I want to thank you, Ian, for joining us for this lovely panel discussion.
Yeah, thanks for having me.
Yeah, of course. And thank you, Johnny, for co-hosting as always. Hopefully we didn't get too meta for our listeners out there.
Just the right amount.
Just the right amount.
Get your episode requests submitted at gotime.fm/request. That way we know what you want to hear about on the pod. And hey, if you're digging Go Time and you don't listen to the changelog, well, you're missing out on some seriously good conversations. We recently had Jessica Kerr on the show, and she expanded the way I think on multiple dimensions.
Our job as developers, I don't want to think of it as writing software. I think of it as changing software, because that extends forever into the future. So step 1, get it out there. Step 2, change it. Step 3 through infinity, change it.
Check out the changelog at changelog.fm or make the Galaxy Brain move and subscribe to our master feed. It has every episode we produce across all of our shows. Let your podcast app do all the work and you get to pick and choose which episodes to listen to. Why not, right? Special thanks to our partners at Fastly for CD ending for us, to Breakmaster Cylinder for keeping our beats fresh and banging, and to you for listening. We appreciate you. Next week, Matt and Johnny are talking instrumentation with 2 special guests, so stay tuned. That's coming up next time on Go Time.